Welcome back, y'all. In this video, I'm making the same thing I made in the last video, but I've learned some stuff since then. What I made was mostly not the terephthalate like I thought. It was the dihydroterephthalate, and the small amounts of the former contaminating the latter lowered its melting point enough to make me think otherwise. This tracks with the relatively wide range of the melting points of the products. I want more quinacridone to try making quinacridone gold with, so I'm making more. I'm using a different experimental procedure, however. Instead of the one in the patent, I'm using the one in what I'm pretty sure is the first recorded synthesis of it in a paper from 1914. The procedure uses proportionately a lot less aniline, which was used in like 5 times excess in the patent, whereas in this one it was a little over a 2 times excess. An explanation for the reasoning behind the conditions in the patent is in the description. It has to do with industrial efficiency, more or less, and cycling forward, which is just general industrial chemistry, and obviously this is not industrial chemistry, so this is the better way for me. I decided to use all of the free aniline I had left in the amounts shown earlier. All that's necessary is, after adding everything to a flask, for it to be boiled for a few minutes, and that's the reaction. Once it's cooled, it's filtered, the flask is washed out, and the product is washed with some ice-cold ethanol. I boiled down the filtrate to see if I could recover a second crop of crystals, and while it did work, the small amount I got wasn't worth the effort in hindsight, and recovering the solvents through fractional distillation probably would have been a better idea. The 1914 paper purifies the crude product by recrystallizing it from amyl alcohol, and I could do that, but it would have lowered the yield, and I'd rather have more less pure product than less more pure product to work with for the future reactions. Instead, I did the same thing as I did in my last video, which is melting both crops in petri dishes to remove any volatile compounds. After that, this is what I ended up with. This procedure is better yielding than the one from the patent by about 5%. Both are great, but this one's better. And that's about all I've got. Thank you all so much for getting me to 1,000 subscribers. I truly mean that. If you enjoyed this video, like, comment, and/or subscribe. It helps me out a lot, and I will see you in the next video.